Start with a right side short axis view of the left ventricle. The transducer is held perpendicular to the right thorax. Remember to anchor your elbow to the rubber mat and anchor your index finger to the patient's body to prevent unintentional image drift. Fan or slide toward the heart base until the mitral leaflets are seen. In this view, you see the anechoic chambers of the right ventricle and the left ventricle. You also see the right ventricular free wall in the near field. The interventricular septum separates the right and left ventricles. The left ventricular free wall is in the far field. This view is also known as the fish mouth view because the mitral leaflets in motion look like the opening and closing of a fish mouth. The anterior mitral valve leaflet is the one closest to the transducer. The posterior leaflet of the mitral valve is the one further from the transducer. As in the previous position, turn on the M-mode function of your machine and use the trackball or touchpad to place the M-mode cursor line through the center of the left ventricle and mitral valves. It may be necessary to angle the transducer cranially to move the heart to the left side of the screen. Activate the M-mode function and you see an image like this. At relatively slow heart rates, you see an E wave and an A wave. These two waves are made by the anterior mitral leaflet. At faster heart rates, both waves will merge into a single wave. During left ventricular systole, a high pressure of about 120 millimeters of mercury in the left ventricle forces both mitral leaflets to close. Pressure in the left atrium and pulmonary veins is only about 5 millimeters of mercury. The E wave results from the opening of the mitral valve due to relaxation or diastole of the left ventricle after full systole. Because of low or negative pressure in the left ventricle during diastole, blood flows from the left atrium and pulmonary veins into the left ventricle. As the left ventricle reaches 75% of capacity, pressure equalizes and the mitral valves begin to close. The A wave results from a second opening of the mitral valve due to left atrial contraction. Both the E wave and the A wave occur during left ventricular diastole. The A wave is normally not as tall or as wide as the E wave. Freeze an image and use Cinematic Loop to choose an E wave that comes closest to touching the septum. Turn on the calculations package of your machine and choose the E-point to septal separation measurement, or EPSS. The E-point to septal separation is a measurement of how close the anterior leaflet of the mitral valve comes to touching the septum. Place one caliper at the point of the E wave and the other at the septum directly above the E point. Note that I used the left side of the horizontal bar of the calipers to make measurements. Save the measurement to the patient record. In cats, the measurement should not exceed 0.04 centimeters or 0.4 millimeters. In dogs, the measurement should not exceed 0.6 centimeters or 6 millimeters. Measurements that exceed these limits suggest an enlarged left ventricle.